Hello everyone. So in our previous video, we saw that how we can remove a key from a hash table, and we saw the working of the code through an animation. Now in this video, we'll actually code the remove method which takes in a key and return us back the value associated with the key which we are trying to remove. So here in our previous videos, we saw how we can put key value pair, how we can get a value corresponding to a key. So now we'll see that how we can remove the key. So friend, at the start, I'll simply copy this part. So here if we are passing key as null, then we are simply throwing an exception saying key is null. So this is the illegal argument exception which states that key is null. So this is the simple edge case. And now in order to remove a key, what we do is we pass this key to our hash function, and this hash function will return us an index where we can search for this key, and once we find that key, we simply remove it. So it will return us back the bucket index. After getting the bucket index, we access the hash node at that bucket index, and as that index is pointing to a hash node which is the starting point of the list corresponding to this bucket index, we give a name to it as head. So friends, here you can see that these two steps are being used in get method also and in put method also. Now what we do is, in order to remove a key, let's say at this index, if I simply copy this part, and here at this index, let's say we have this list of hash nodes, something like key as 21, value as Tom, now let's say it has 3 nodes, something like this. Where key 31 has value Harry and key 41 has value, let's say, Sana. Now head is pointing to this node because this is the first hash node of the list. Now our task is to remove this key. So let's say if we want to remove the key as 31 and head is pointing to this. So first we will search our key by traversing head to each and every node. And if we find the key, let's say if we find the key 31, so somehow we need to access this hash node because this link needs to be removed in order to free this node. And if we free this node directly, then all the nodes after this node will also be removed. So what we need to do is, as head has traversed to this node, so first we simply keep the track of its previous nodes. So wherever head will go, we will keep a reference to its previous node, which is very important while removing a key from the hash table. So if head is here and key matches, so previous will be here. So to previous next, we have to break this link. So to previous next, we need to assign head next because we need to keep these nodes intact. We will assign head.next value to previous next. Head.next is this node, and the nodes after that, it will be assigned to previous next. So this link will go away from this node to this node, and then we can simply remove this hash node. So for that what we do is, at the start we create a previous hash node, we assign it a value as null because as head is pointing to this node, at start we are doing previous as null. So now what we do is we search for the key. So for that we provide the while loop, and here we will use the same while loop which we did in the get. So here we are providing the condition as head should not be equal to null, and if head is equal to null, it means we have traversed this complete list and we didn't find our key. And if head is not equal to null, what we do is we compare head.key with the key which we want to remove. And after we find our key, what we do is we simply break from this while loop, because after this while loop, head will point to the key which we want to remove. Let's say here 31. So head will point to this key because this condition matches. So let's say if we take this example and if we want to remove a key as 31. So in this while loop, head will first check it with 21. This condition comes out to be false. Then we go to its next node. Head will come here. It is not equal to null. Then we'll compare head.key, which is 31, with the key which we have passed to this method. So as soon as we find our key, head is pointing to this node. And here what we do is, before moving the head to its next position, what we do is, how can we keep the track of this previous node is, we first assign head to previous. So previous and head will point to this node, and then we simply traverse head to its next node. So previous is a step behind the head, and why we are keeping previous just behind the head is because let's say we have searched for the key which we want to remove. So we break from this while loop, and as soon as we break from this while loop, previous is here and head is here. So after this while loop, what we do is we first check that if head is equal to null or not. So if head is equal to null, it means we didn't find any key in this list, because this while loop would have terminated when head would have pointed to null, which is the last node next. So if head would have reached here, it means we haven't found our key. So we are simply returning the null value. And if head is not equal to null, then the first thing we do is we decrement the size by 1, because now we are about to remove the key. So here now two condition arises. One is at the start, previous is pointing to null and head is pointing to, let's say, 21. And what if we want to remove 21 only? So in that case, we are simply removing the first node of this list. And how we can come to know that is the first node only is via the previous, because if previous is null and after this if block, we can come to know that head is not equal to null. So it means head must be pointing to this node only, and which means we have to remove this key. So here we provide the if condition and we check that previous is equal to null or not. So if previous is equal to null and if our code has reached here, it means head is also not equal to null, which signifies this head is pointing to the first node. So in the else part, what we do is we have to remove the first node, and it is being referred by this, the hash node at bucket index is the first node. So here what we do is we simply reassign this value to something like we do head dot next. So it means that our buckets array at this bucket index was pointing to a hash node to which our head was also pointing, and now we need to remove this node. So head is pointing to this node. If we assign head dot next to this, then this node will be removed easily, and now our buckets array at bucket index will point to this node, because 21 would be removed. So this is the small change which we do if previous is pointing to null. And if previous is not pointing to null, now let's say if we want to remove 31, so head will point to this and previous will point to this. So now instead of doing this stuff, what we do is we do previous dot next and we assign head dot next to it. So here you can see head dot next remains the same. As previous is not equal to null, it means we can't use this stuff, because this is only used in case if we want to remove the first node of the list. But if we want to remove, let's say, a node in the middle, then previous will help us in removing that. So head was pointing to this and we want to remove this, and previous was pointing to this. So to previous next, we assigned head next this value. So now this hash node next will point to this hash node, and this hash node can be removed easily. So this step does that. So after this reassignment, head is still pointing to this. So at the end what we do is we simply return head.value, and once this method will get terminated, this head is our local variable, so it will be garbage collected. So friends, what we did in the remove method, we took the key, we evaluated the bucket index where this key might lie. The starting hash node we denoted with head, we created previous, and at the start we provided a null value to it. And now in the while loop, we tried to compare each and every key with the key which we want to remove, because if we don't compare, then we will not able to get which node we want to delete. So as soon as we found the key which we want to delete, we break from this while loop and we perform the assignments here. But let's suppose if the key is not found for the first iteration, then what we do is we have to move head to its next node. But if we move head to its next node, we can't delete this node. We need to keep the track of its previous node as well. So before moving head to its next node, we are assigning the value of head to previous, and then we are moving head to its next node, so that when we will find any key in the middle, we have reference to a node before that, so that we can reassign its next pointer. Here you can see we are reassigning it. So if the key which we want to remove is at first node, then we simply assign head.next value to buckets array at this bucket index. And if it is somewhere in the middle or end, then we have this previous reference. We simply assign head.next to previous next. And finally we return head.value. And once we return head.value, this method gets terminated and the node gets freed up. So now let's test its working in the main method. So here you can see, let's suppose we have this 3 keys, 105, 21, 31. And if I run the code now, you will see size will come as 3, because there are 3 hash nodes or key value pair. Now what we do is, let's say we remove 21 and we print its value on the console. So here you can see it printed Harry, because Harry was associated with key 21. Now let's say if we want to remove 31. So now if I run the code, you can see it printed Dinesh. And if I print the size of it, so here we have removed 2 nodes. So it should print 1. So it has printed 1. So here you can see only 105 remains in the hash table, because we have removed 21 and 31. So here if I simply copy this part, so here before removing these 2 values, we had hash table something like this. This is 3. Dinesh 21, Harry, and let's say if I remove this for time being. So this was our hash table at index 1, because we are removing 21 and 31. So if we evaluate the bucket index, 21 divided by 10 will give remainder as 1. So this is for the index 1. We first added 21 using put, and then we added 31. So 31 came before 21 because we are inserting the hash node at the beginning of the list. So this was the situation. So when we removed 21, head started with this node, then it reached here, and previous reached here. So 21 matched with our key, and at the end what we did, previous next was assigned with heads next, which is null, and then we removed 31. So this node was removed, and when we printed the size, it printed 1. Only this key value pair exists, and we removed these two key value pairs. So friends, I hope you have find this information useful, and in case if you have find this information useful, then please like this video. If you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day.